All right, so today we'll be going over a brief lesson on graphing an ellipse. So the equation you see, quantity x minus h squared over a squared plus quantity y minus k squared divided by b squared over b squared equals 1, where a is greater than b, is one of the standard equations we have for an ellipse. Okay, and if you get your equation in this form, you can go ahead and graph the ellipse fairly easily. A couple things, you have what we call A and B here, these two numbers. A stands for the length of the semi-major axis, and B stands for the length of the semi-minor axis. So if you look at the picture, the major axis basically is this axis right here that goes between these 2 points called vertices, and then you have the minor axis, which has this length right here. So there's always like these two axes, and I like to think of it as like two radiuses here. Okay, all right, so have that, and we also have a point here which we call the center right here, and that is labeled with h comma k, which is kind of like the opposite sign of the numbers I have up here. Now you have, as I said, you have these points called vertices and a couple notes. If a equals b here, you have a circle. Okay, so that's really why not. We're not talking about a being greater than b here. That's like, that has to happen for you to have an ellipse. Technically speaking, there's a couple other points on here. They're called the foci, and they're like inside the parabola, and that would be like right here. I'm sorry, inside the ellipse here. Yeah, you have these 2 points, two foci. I'm not really going to speak about that here, though. Just to let you know, though, technically they're on there. In terms of the graphing, though, I don't think you really need them to get a nice picture of what the graph looks like. And just another thing, there's an equation that the distance has to satisfy c, which is c squared equals a squared minus b squared. That always has to happen. All right, so you can have an ellipse for which it's wider on an axis that's parallel to the x, and it kind of looks like a football, like what you see here. Or you can have one that looks like what I have down here, which is it's longer on the vertical axis, and people think of it as an egg. In this case, you have a different equation, and the only difference, because these equations look very similar, the only difference is that the a squared is under the y, the term with the y, and the b is under the term with the x. That's the only difference. Okay, and same ideas here. You have a major axis, you have a minor axis, you have the a and the b, all that not changed. The only thing is that the a here is the length of the major axis, the semi-major axis is parallel to the y-axis, it's vertical, and b, the semi-minor axis, is horizontal. That's it. That's the difference between the equations here and above. All right, so let me get to an example here. Graph 4 times x minus 1 squared plus 9 times y plus 2 squared equals 36. So the first thing to notice is that this is not in the form of what I have here, okay, or up there. In terms of that equation that I have. So I have to make it equal to 1. In order for you to graph this, you must have 1 on the right-hand side. So what we do is we go ahead and divide by 36 on both sides. So that means each individual term on the left will be divided by 36. And that gives us x minus 1 squared equals over 9, plus y plus 2 squared over 4, all equal to 1. First thing I'm going to do is I'm going to grab my center, which is 1, -2. So it's just the opposite signs of the numbers that are attached to the x and the y. You have a squared, which is 9. So a squared is just the larger number out of those two that are in the denominator. So a would equal 3. And b squared is 4, or b is 2. So a, again, is the length of the semi-major axis is 3, and b is the length of the minor axis, which is 2. With all this, that's all you need to graph the ellipse. And if you go down here to my xy axis here that I drew, I have 1, -2 as my center. So I'm going to go ahead and go where that's at, which would be like right here. And then here's what you do. I'm going to start with the a equals 3. So that's telling you you're going to go 3 units horizontally in each direction. So 1, 2, 3. You will land at these 2 points right here. And these 2 points, because they're at the end of the semi-major axis here, both directions, these are the vertices. So 4, -2, and -2, -2. Okay. A couple other points I'm going to get are the points that are right above and below the center, which are 2 units away because the B was 2. So 1, 2, 1 right here. And this would be 1, 0, and then 2 below, right here, which would be 1, -4. Okay. Those points themselves don't have names to them. They're just help you to get a graph here. But these points here, -2, -2, and 4, -2, those are vertices. And all you have to do is connect those points on the outside, and we're done. That's our graph. All right. A couple of things to know. There's other things that can come up in terms of graphing an ellipse in terms of like the way the equation's presented. So another example would be graph the ellipse 4x squared plus 16x squared plus 9y squared minus 18y plus 17 equals 4. Okay, that is actually an ellipse. It's, in a way, I'd like to say it's kind of hidden, and the only way you can get it into the form that you have up here, the way I presented the original equations, is if you complete the square on both the x and the y. So you would, have to factor a 4 out of the x squared and the 16. I'm sorry, that's supposed to be a 16x. I apologize. The 4 out of the 4x squared and the 16x. And if you're not familiar with completing the square, I'd recommend checking out another video that I made on that. And I'd factor out a 9 out of the 9y squared, the minus 18y, and any constants go on to the other side. So 4 minus, subtract 17 from both sides, and it gives you minus 13. And what you would do is you would go ahead and complete the square on both parentheses, and then you'd finally get something like what you have up here, okay? All right, and I hope this helped. Thank you for your time.